Alright, this video is a math help video for 070206D, water properties and buoyancy. Okay, so the first real math question doesn't happen until the self-test on question 8. That question's asking what's the buoyant force available on a 5 cubic foot object if it's immersed in water. Okay, so remember the buoyant force is equal to the weight of the water displaced. So imagine you had a bathtub, it was completely full, and you took this 5 cubic foot object and you immersed it in the water. How much water would overflow over the sides? Well, the volume, right, would be 5 cubic feet. And if I took all that water and I weighed it, how much would it weigh? It would just be 5 times 62.4, because that's the density of water, right? So therefore, that's my buoyant force, the weight of the water displaced. How much does the weight of all the water that went over the sides of the tub weigh? It would weigh 5 times 62.4. It would be 312 pounds. Okay, so all right, question 9 is asking what the volume of an object is if it weighs 925 kg in the air, but only 570 kg when weighed in water. So if it weighed 925 kg in air, but only 570 in water, what happened to the rest of the weight, right? So the difference is the buoyant force, right? The water's picking up the difference. So therefore, the buoyant force is equal to 925 minus, minus 570, or 355 kg. Okay, so the buoyant force is 355 kgs, and remember the density of water is 1,000 kgs for every meter cubed. Okay, so if this object was 1 meter cubed, it would weigh 1,000 kgs. The buoyant force would be 1,000 kgs. The buoyant force of this object is 355. So to find the volume, all I do is 355 divided by 1,000. And you should get 0.355, and that'd be cubic meters. Okay, so the answer is D. Okay, question 10. So there's an object that has a volume of 0.658 cubic feet and it weighs 40 pounds. If you placed it in water, what would it do? Okay, so the first thing that I would do is I would just compare it to water, right? If its density is more than water, then it would sink. And if it's less than water, then it would float. So remember, density is pounds per cubic foot. So to figure out this object's density, I would just go 40 divided by 0.658. 40 divided by 0.658 equals 60.79. And that would be pounds per foot cubed, pounds per cubic foot. Okay, so remember what was water? Water was 62.4. So it's less dense than water, which means it's going to float. But it's not a whole lot less. So it'll barely float with most of the objects submerged. It would be C. Okay, and we can take this question one step further, and we can figure out its relative density. So we can go 60.79, and we'll divide that by 62.4, and that is 0.97420 something or other. Okay, that would be my relative density. So remember, if its relative density is less than 1, then it floats. If it's greater than 1, then it sinks. You could also say it's about 97.5 the density of water, which means like, imagine this thing was, uniformly dispersed, like it was all the same, it was like a sphere or something, and it was uniform and how like the same material, same density all the way across. Well, imagine it would be like this. It would float like this, where 97.4 would be below the water. And then I guess it'd be the difference, like 2.6% would be above the water. Okay, that's another way to think about it. Okay. Okay, and finally question 11. How much extra weight would be required to sink a sealed drum if it had a volume of 2.725 cubic meters and a mass of 22.7 kg? And it tells us to add 1 kg just to make sure it sinks. Okay, because remember, if something's the same density as water, it'll just bob around in equilibrium. But we want to make sure it sinks, so that's why we're going to add 1. Okay, so the first thing we have to do is figure out the buoyant force. And then we just have to make the mass greater than the buoyant force, right? That's all we have to do, right? If something weighs more than its buoyant force, it sinks. If it weighs less than its buoyant force, it floats. So let's figure out this object's buoyant force. It has a volume of 2.725 cubic meters. And we're going to multiply that by 1,000, because remember the density of water is 1,000. So therefore the buoyant force would be, I guess I can do this in my head, 2,725 kgs. Okay, and it only weighs 22.7. So we got to add a bunch of weight to it. How much do we have to add? Well, we just go 2725, because that's the buoyant force. And remember, it weighs 22.7, so we take that off, and we got to add 1 just to make sure it sinks. So it says 2725 minus 22.7 equals, plus 1 should be 2,703.3. Okay, that's how much we would have to add. And you can so that's the answer. That's our answer, 22703.3. I guess it would be C. And we can work it backwards. So 2703.3 plus, remember, it weighs 22.7 plus 22.7. Let's see what that weighs. Plus 22.7. And I get 2726. Okay, so this would be the total weight of the object now. Is this more than this, than the buoyant force? Yeah, it's 1 greater, so that means it would sink. Okay, so remember, if something is heavier than its buoyant force, it sinks. If it's lighter than its buoyant force, it floats. And if it's equal to its buoyant force, then it bobs around in equilibrium. Right, and that's the end of the math help video.